Welcome back, everyone. Today we're going to be solving this trigonometric equation. So let's dive in and talk about how to do this. Okay, so first thing is we want to isolate the trig ratio of sine of x minus pi over 3. So to do that, I'm just going to divide both sides by 2 and get that this is equal to sine of x minus pi over 3 is equal to 1/2. So that's the first thing. The next thing we need to do is we need to use the special triangles to identify, well, when does, the sine of something equal to 1/2? Well, for that, we're going to use the pi over 3, pi over 2, pi over 3, pi over 2, pi over 6 special triangle. So I'm just going to draw a quick sketch of that here. So here we have pi over 3, root 3, pi over 6, 2, 1, like that. And so as you can see, the sine of pi over 6, right? The sine of pi over 6, according to this special triangle, is equal to 1/2. Now, in the first cycle, from 0 to 2 pi, in other words, are there any other places other than pi over 6 where we would have 1/2? Well, let's check. Let's draw a diagram here and check to see what that would look like. So remembering the cast rule states that in quadrant 1, or we have the word cast like this starting quadrant 4. So in quadrant 1, all of the trig ratios are positive. In quadrant 2, only sine is positive. In quadrant 3, only tan is positive. And in quadrant 4, only cosine is positive. And so I'm going to highlight where sine would be positive. So sine is going to be positive in the first quadrant because A stands for all three of them, including sine. And then S stands for sine. So in these first two quadrants, we would have something positive. And notice that over here, 1/2, this is positive 1/2. And so therefore we only need to look at where we would get a positive answer. Places where we would get a negative answer, we automatically can't get a positive 1/2. That wouldn't make sense. So pi over 6 is one of those places. And then also over here, whatever the equivalent is in the sine quadrant where this is pi over 6. Now keep in mind, this is 0, pi over 2, pi, and 3 pi over 2. And then this, would be 2 pi as well, right? We'll have one full cycle. And so what is this value here? If we have pi over here, and then over here we have pi over 6. Well, this would just be pi minus pi over 6. That's what this angle over here would be. I'm going to draw the angle I'm talking about. Therefore, this angle would be 5 pi over 6 because the two angles together would have to be a full pi. And so therefore, that's the answer. That tells us that sine of pi over 6, or 5 pi over 6 rather, also is equal to 1/2. And so there we go. That's going to be very useful for us. And again, we know that we don't even have to consider the bottom two quadrants here because in these ones, sine would be negative in either case. And here we're looking for where it's positive 1/2. Okay, so now what we need to do in order to find the answer is we need to figure out, well, where would it be true that x minus pi over 3 is equal to pi over 6, or where x minus pi over 3 would be equal to 5 pi over 6. We need to figure out both of those things. Okay, so for this first one, I'm going to add pi over 3 to both sides. We would get x is equal to pi over 6 plus pi over 3. That it means that this would be pi over 6 plus 2 pi over 6 if we multiply both by 2. And then we're going to get 3 pi over 6, which is pi over 2. So that's our first answer, pi over 2. Okay, now let's do the same thing here. Let's add pi over 3. So if we do that, we get x equals 5 pi over 6 plus pi over 3, which I'm actually just going to automatically put in that pi over 3 is the same as 2 pi over 6. And that's going to equal to 7 pi over 6. Now, if we were just asked to find the answers for this from the first cycle, we could just say, okay, well, those are our answers. It's pi over 2 and also 7 pi over 6. and then that's the end of it. However, they actually didn't in this case give us a specific domain, and so therefore they want all the answers. So anytime that we go up or down by 2 pi or some multiple of 2 pi, we're actually going to end up with this 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 arm in the exact same spot, just on a different cycle. And so that's why I'm going to add to these ones plus 2 pi k plus 2 pi k, where k is any integer, right? Because if we go back 1 cycle or forward 3 cycles or back 100 cycles, forward 35 cycles, whatever it might be, any and all of those would still also work and be solutions, right? And so that's why we have to include the plus 2 pi k. If we're given a certain domain, then that's not the case. Then we just have to find the values that are within that domain. But in this case, they just said to give all solutions. And so these would be the solutions over here. As always, feel free to put any questions you might have in the comment section, and we'll see you for the next one. There will be a few more videos like this with solving trigonometric equations because all of them are slightly different. It's good to see a few examples. But yeah, we'll see you for the next one. Bye for now.